So here's an investments problem for you. Suppose that I have $1,000 to invest, and I want to put it into an investment that earns 100% over a course of a year. Most investments do not do this. I'm investing in some risky Wall Street bets kind of stock options contract, right? So let's suppose that it increases in value by 100% over the year. So my question is, would we rather get all 100% of that increase all in one lump, or would we rather get two 50% increases? So split the 100% in half and get 50% once and then 50% on that again. Or would I rather get 10% increases? So that's my first question, just for large group discussion. What do you think is the best option for me? So your intuition is correct, that it's a better idea for us, if we want to get more money, and I certainly do, to split up that 100% into increments and get continuing increments. Because 10 increases of 10%, each successive increase of 10% is on a larger base than before. Right? I increase by 10%, then I increase that by 10 of its percent, then I increase that by 10 of its percent, and so on. So the hunch that we have is that over the course of the year, the more intervals that I choose to compound, that's what compounding means when you talk about interest, the more intervals that I choose to compound my interest rate, the higher that my balance is going to be at the end of the year. So if I just got my increase in one lump sum, if I start with $1,000, I end the year with $2,000. Right, 100% increase on my 1,000. But if I take and I turn that into two increases of 50%, then I get 50% in the middle of the year, and I end up with 1,500. But then I take 50% of my 1,500, which now is 750, and I add that 750, and I end the year with 2.25. So I have gotten more by compounding twice. If I compound 10 times, now I'm getting 10% increases 10 times over the course of the year, and I end up with 2,594. So what do you think is going to happen if I keep increasing that number of compoundings? This end of the year balance is going to keep increasing. How high can it go? Can it go infinitely high? Can I somehow get infinite money out of this scheme?
Technically, if time was irrelevant.
if time could be infinitely subdivided.
Exactly.
Except that my interest rate is still fixed for the year at 100% interest rate per year, right? So there's got to be doesn't there have to be some limit to how much money I can earn over the course of the year in this scheme? Because I'm dividing that same 100%, I'm just dividing it into successively smaller intervals, right? Well, let's try it. I mean, this is what technology is great at, right? Let's just go from 10 subdivisions, 10 compounding intervals to 20. So I'm still getting more money, right? It's just, 2,646. Let's go to, 3 times a month, 36 subdivisions. So I still have more, but it's not that much more than it was before. It's starting, that increase is starting to level out a little bit. It does seem like there is a limit to just how much more money. Well, it may well just do that. Let's see if we can draw this out to 1,000 increases. It's really starting to increase slowly now. Let's dial it out one more time. Let's go to 10,000 subdivisions. It doesn't look like it's changing anymore.
No. 0, 1 increase.
Yeah. So if we could have more. Yeah. This is why we're talking about this. We actually have a few more decimal places right here, so we can see that it is still changing just a little bit. It's not changing to 3 decimals, but it's still changing a little bit. But it does seem to be leveling out. And this number that it's leveling out to, by definition, this is the number that we call E. Right? E is the factor, the number that we multiply by for a 100% increase that has been subdivided infinitely much and compounded infinitely many times over the course of the year, right? And so it's this constant. It's this number that's approximately 2.71828182846. That's as much of E as I know from memory. I know a lot more of pi, just because when I was like 6, I decided to take it on myself to memorize a bunch of digits of pi. E is apparently less interesting, but it's still quite interesting, right? But I don't want to make more out of E than we need to. For today, we're just going to think of it as being this funny number that has a very long decimal expansion, infinitely long, in fact, and never repeats itself. It's an irrational number. But what we're going to endeavor to do next, so where we go next with this, is when we come back in our next class after spring break, so I wish you a happy spring break preemptively, we're going to see that every exponential function can be written using e as its base, and that when we do that, it gives us a new way to understand how all exponential functions are, again, graph transformations of a single kind of exponential function, in this case with a base of e.